Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching food machinery in BE 5th semester, and today we will study Peltonville Turbine. Dear students, this is Peltonville Turbine. Here this is the runner, and some vanes are fixed in the runner, and these vanes are in front of the jet of water, and that jet is controlled by this nozzle and spear arrangement. If you make the spear forward, then there is no jet passing through this nozzle, and if we do this sphere in the backward position, then the nozzle is fully open to make a jet force to this vane, and after striking this vane, this runner and vane is moving in this direction, anti-clockwise direction, and the power generator are connected to this turbine, and the power is produced. This whole arrangement is under the casing, and this is open to the bottom, so if 100% water not strike to the vane, then some water may be left down from this side. It is possible that 100% water may not strike the vanes. So this is normal pressure range. Here no special pressure is provided, and this is generally because of just only of kinetic energy of the jet, and these waters are connected through the dam to this penstock to the nozzle, and here the parts of Peltonville turbine. This Peltonville turbine is the name is on behalf of L.A. Pelton, an American engineer who has developed this Peltonville turbine. On behalf of him, the name of turbine has been written as Peltonville turbine. Here the parts of Peltonville turbine. The Peltonville turbine is tangential flow impulse turbine. The water strikes the bucket along the tangent of the runner, like this, tangent to the runner. The energy available at inlet of turbine is only kinetic energy. Here energy is only kinetic energy available to the runner. The pressure at inlet and outlet of turbine is atmospheric. This turbine is used for high head and is named after L.A. Pelton, an American engineer. This is high head turbine. High head turbine. Because only kinetic energy is sufficient for rotating the runner. Here the figure shows the layout of hydraulic power plant in which the turbine Peltonville. The water from reservoir flows through the penstock to the outlet, of which is connected to the nozzle fitted at the end. The nozzle increases the kinetic energy of water flowing through the penstock. At the outlet of nozzle, the water comes out in the form of jet and strikes the buckets or vanes of the runner. The main parts of Peltonville are nozzle and flow regulating arrangement. Second is runner with bucket. Third is casing, and fourth is braking jet. We will study all these one by one. In the nozzle and flow regulating arrangement, the amount of water striking the bucket vanes of the runner is controlled by providing the sphere in the nozzle. This sphere is provided. The sphere is a conical needle which is operated either by hand or wheel or automatically in axial direction. Some wheel is provided there, or this may be used automatically, where the sphere is pushed forward in the nozzle in the forward position, then the amount of water striking runner is reduced. On the other hand, if the sphere is pushed backward, when the sphere is in the backward position, then all nozzle is open and the more water can be supplied flowing through this penstock. Here the striking the runner increases. Then next, runner with the bucket. This figure shows the runner of Peltonville. This is the runner of Peltonville. Here buckets consist of circular disc on periphery of which a number of buckets evenly spaced are fixed. Here the shape of the bucket is of a double hemispherical cup or bowl. This is the shape of the bucket and bowl. Each bucket is divided in two symmetrical parts. These are the two symmetrical parts by a dividing wall which is known as splitter. This one is dividing wall is known as splitter. यहाँ पे जो भी पानी ऐसा स्ट्राइक करता है वो आधा इधर चल देता है, आधा इधर चल देता है. ये बीच में स्प्लिटर है. जैसे ये एक चम्मच है और ये एक चम्मच है और दोनों को हमने जैसे ऐसा जोड़ के रखा हुआ है. ठीक है, ये बीच का स्प्लिटर है. आधा इधर चल देगा, आधा इधर चल देगा. ठीक लगभग इस टाइप का शेप रहता है जिससे ज्यादा से ज्यादा पानी वहां पे स्ट्राइक हो और आपके रनर को रोटेट कर सके. नेक्स्ट इज केसिंग. द जेट ऑफ this figure shows a Pelton turbine with a casing here, outer body. This is called as casing. The function of casing is to prevent the splashing of water and to discharge water to the tail race. All of this water inside this discharge the tail race at the bottom side. This is the tail race. It also acts as safeguard against accident. This is moving, waves are moving with high speed. So if someone want to go for inspection, then someone put your hand here. So for safeguard of the person from the accidents, because this speed of RPM of the runner is 1000 to 4000 RPM. So it is very important for safeguarding against the accident. It is made of cast iron or fabricated steel plate. Cast iron or fabricated, this is cast iron or fabricated steel plate. Steel plate. Cast iron or fabricated steel plate. This casing has been done. The casing of Peltonville does not perform any hydraulic function. This casing has no hydraulic involvement. Next is braking jet. When the nozzle is completely closed by moving the sphere in forward direction, the amount of water striking the runner reduced to zero in the forward position. The inlet water is stopped, but runner due to inertia goes on revolving for a long time. But after braking this jet, runner is moving due to its inertia. To stop the runner in short time, a small nozzle is provided which directs the jet of water to the back of fence. This jet of water is called braking jet. Here in any place some provision is here for braking jet that fall on this direction, backside of the jet, backside of the runner vanes to stop this running of this. One thing I want to discuss again with the runner with bucket. The jet of water strikes the splitter. The splitter divides the jet into two equal parts, and the jet comes out at outer edge of the bucket. The buckets are shaped in such a way that the jet gets deflected through 160 to 170 degree. The buckets are made of cast iron, cast steel, bronze or stainless steel depending upon the head at the inlet of the turbine. Now we have to calculate the forces etc. for this Peltonville turbine force and its efficiency etc. For this the velocity triangles here made are, this is the inlet is of in straight line and outlet, because this is in half position, so this upper half is discussed. Similar is the down half. Here the entrance is the same, inlet is the same, and this is the Peltonville turbine. This is the Peltonville turbine. Okay, this is the Peltonville turbine. Half of water comes in this side and half of water strike in this side. So this is the outlet triangle. Here this is VR2, this is V2, VF2, this is angle beta and phi, this is U2 and VW2. And at inlet, this is U1, VR1, VW1 and total is V1. So we'll use this in the calculation here. Let H is net head acting on the Peltonville, net head acting on Peltonville, that is equal to Hg gross head minus Hf is the friction head. As we know, Hg gross head is equal to Hg is gross head and Hf is 4FL V square by D into 2G. Here D is dia of penstock. This is D dia of penstock. N is speed of field in RPM. Speed of wheel in RPM. D is diameter of wheel. D is diameter of wheel. Dia of wheel. D is diameter of jet. Then V1 equal to velocity. V1 equal to velocity of jet at inlet. Velocity of jet at inlet equal to this V1 is equal to root 2 GH and as we know U equal to U1 equal to U2 equal to pi dn by 60 pi dn by 60. Here this is dia of V. Okay. Next, the velocity triangle at inlet will be straight line as I have shown earlier. So here VF1 equal to V1 minus U1. V1 is over minus U1 is VF1, that is equal to V1 minus U, that is equal to V1 minus U. Then VW1 equal to V1 alpha equal to 0 degree and theta is also equal to 0 degree in the inlet side, both are. So from the velocity triangle at outlet from velocity triangle we know VR2 equal to, as we know, VR2 equal to VR1 and VW, now VW2 equal to, we know, VR2 cos phi, VR2 cos phi minus U2. These equations we have done earlier also. So the force exerted by jet of water in direction of motion is given earlier, we have solved in different turbines. Fx equal to rho a V1 in bracket VW1 plus VW2. As the beta angle is an acute angle, positive sign should be taken. Also, in this case of series of when the mass of water striking is rho a V1 and not rho a VR1. Mass of water striking is rho a V1, and here A is the area of jet, which is given as area equal to pi by 4 d square. This we know, pi by 4 d square. Now work done by jet on the runner per second, work done is equal to Fx into U. So putting the values here, rho a V1 VW1 plus VW2 into U, Newton meter per second. Power given to the runner by the jet. Now power is in the kilowatt, that is rho a V1 VW1 plus VW2 into U by 1000. This is Newton meter per second, or this can be replaced by watt. So here by dividing the 1000, this is kilowatt, and power is generally in the kilowatt. This is the bigger unit. Now work done per unit weight of water striking per second, work done per unit weight of water striking per second. here this is rho A V1 VW1 plus VW2 into U is divided by weight of water striking per second. Weight of water striking per second. So here this is rho A V1 VW1 plus VW2 into U by rho A V1 into G. Rho A V1 into G. Now rho A V1 and rho A V1 are cancelled. So this is 1 by G VW1 plus VW2 into U. This is the work done per unit weight of water striking per second. Now the energy supplied to the jet at inlet is in the form of kinetic energy and is equal to half of mv square. Here kinetic energy of jet per second, this is the kinetic energy equal to half of mv square. So the kinetic energy of jet per second equal to half of rho A V1 into V1 square, that is equal to half of rho A V1 cube. Now hydraulic efficiency that is eta hydraulic equal to work done per second by kinetic energy of jet per second. Kinetic energy of jet per second. So putting the values here, this is rho A V1 VW1 plus VW2 into U is divided by half of rho A V1 into V1 square. So here this is 2 into VW1 plus VW2 into U is divided by V1 square. Now VW1 equal to V1 equal to V1, VR1 equal to V1 minus U1, VR1 equal to V1 minus U1, this is VR1, and that is equal to V1 minus U, V1 minus U, because U equal to U1 equal to U2. So VR2 is equal to V1 minus U, and VW2 equal to VR2 cos phi, minus U2 is equal to VR2 cos phi minus u, VR2 cos phi minus u, that is V1 minus u cos phi minus u, that is V1 minus u cos phi minus u. Substituting the values of VW1 and VW2 in this earlier equation here in the hydraulic, substituting the value of VW1 and VW2. Here eta hydraulic is equal to 2 into, this is V1 plus V1 minus u cos phi minus u. So here and the V1 square, this is divided by V1 square. Now this is equal to 2V1 minus u, 2V1 minus u, taking common 1 plus cos phi into u, 1 plus cos phi into u by V1 square. The efficiency will be maximum for a given value of V1 when d by du eta hydraulic is equal to 0, or d by du 2u V1 minus u into 1 plus cos phi by V1 square. These all tends to 0. That is 1 plus cos phi by V1 square d by du 2u V1 minus 2u square 0, or d by du 2u V1 minus 2u square is equal to 0, because 1 plus cos phi by V1 square cannot be 0. So 2V1 minus 4u equal to 0, or u equal to V1 by 2. This is for the maximum of efficiency. This equation states that hydraulic efficiency of Pelton wheel will be maximum when the velocity of wheel is half the velocity of jet of water at inlet. The expression for maximum efficiency will be obtained by substituting U equal to V1 by 2. So maximum eta hydraulic is equal to 2 V1 minus V1 by 2, putting the value of U, 1 plus cos phi, 1 plus cos phi, V1 by 2, V1 by 2. This is V1 by 2. Now this comes to V1 by 2 into 1 plus cos phi V1 by 2. V1 by 2 is 4 divided by V1 square this one is also divided by V1 square. Okay, so this is V1 square, that comes 1 plus cos phi equal to 2. 1 plus cos phi by 2. So here the important point is that the maximum efficiency will be obtained when U equal to V by 2, when the velocity of field is half the velocity of jet of water at the inlet. Now we will solve some numericals on the next classes. Thank you.